In this video, we'll be solving this problem on the screen. So let me read it first for you. So let x, y, and z be positive real numbers. Let me highlight the positive out here. Following this given equation out here. Our goal is to evaluate this corresponding expression. So before we solve this one, I suggest that you first try this one on your own. Okay, good. So let's begin. So for this problem, let me first begin by naming this thing out here. Let me call this equation to be a star. Let me just rearrange this out here. Take note that from star, if I divide x squared, y squared, z squared in all of this, then on the right side, this this variable part would be removed and we'll be left with a constant. And let's see what would happen on the left side. So that is our first step out here. So let me copy this one. So again, what we are gonna do here is that we will be dividing x squared, y squared, z squared on both sides. So like I said earlier, this thing here would cancel out. So for the right side, we'll be left with just 3. But on the left side, take note that for this first one, x squared would cancel out. The y on the numerator would be gone. And this one would be just one exponent. And this z squared on the denominator will be gone. And we'll be left with just a single z in the numerator. So this thing here will be z over y. And then doing the same process for this and then this, you can obtain similarly that we'll have your x over z and then y over x equal to 3. So by now it's probably kind of confusing what we're trying to build up here, but by doing that process, we are able to, kind of simplify this given into this. So this would be our focus instead. Okay, so that is the key of the goal of the first step, to simplify the given equation. So let me name this thing instead now to be equation diamond. And then from here comes our key step. So for our key step, I would title this, or I wouldn't title it. It is actually called the AM-GM Inequality, wherein I think, if I am correct, AM stands here for arithmetic mean and GM here stands for geometric mean. Yeah. So it's actually not just AM-GM. There's also like harmonic mean inequality to compare each of the means. But for our case, this is only what we need. So for the 3 variable case, so let's say if we have variables a, b, and c, which are non-negative, so technically it's greater than 0, then we obtain the following inequality. A plus b plus c over 3 must be greater than or equal to the cube root of a, b, and c. So that's basically the inequality. And take note that the equality holds out here if and only if a equal to b equal to c. So this would be our key formula in solving this one. Good, so let's use this in practice, or let's apply this one. So to be able to apply this, we need A, B, and C. The most natural choice is for this to be A, this to be B, and this to be C. And that is valid since, recall that earlier I highlighted that x, y, and z are positive real numbers, which means that if we get their quotient, we're sure that this thing will still be positive or non-negative, so it satisfies this. Also, I forgot to mention that is the reason why we can do this, since we know that if x, y, and z are positive, then they are not equal to 0. So we can divide this product out here. Good, so let's do that one. So we set a to be equal to z over y, b to be equal to x over z, and c to be equal to y over x. So doing that, we can obtain that by the AM-GM inequality. AM-GM, let me abbreviate it as INEC only, by AM-GM inequality. We know that our a, z over y, plus our b, x over z, and our c to be equal to y over x all over 3 must be greater than or equal to their products, which are z over y times x over z times y over x. There you go. Okay, good. Then from here, note that this thing is just equal to 3 by earlier, right? So we know that for this left-hand side, if we apply the diamond one, we will be obtaining 3 over 3, which is just equal to 1. For the right-hand side, notice that this thing would cancel, this thing would cancel, and this would cancel. So we'll be left with just a cube root of 1. Cube root of 1 is just simply equal to 1. And what do we have here? So we can see here that 1 is greater than or equal to 1. But we know that in inequalities, if the left-hand side and the right-hand side is equal, then we are forced that this inequality here to become equality. Okay? So when that happens, and so if equality holds, take note that if equality here, if this one is equal to 1, we know that if equality holds, we go back here, we must get that a equal to b equal to c. Or in other words, we will be obtaining that z over y is equal to x over z, sorry about that noise, y over x. But what would happen if this is the case? If this is the case, going back out here, if these three things are equal, and they are equal to 3, it must follow that each of them must be equal to 1. Diamond. Or equivalently, if each of them is equal to 1, or this is just one step away from what we want. Using this equation, x equal to y equal to c, that's why I named it, we can actually now solve our problem, obtaining this expression. So let's do that one. So take note that therefore, by the heart, oops, let me write this properly there. Therefore, by this one, so let me copy this expression. Let's bring it down. I guess out here. So if we apply, let's see, there. If we apply this one, then we can replace every y and z with just x. So we will be left with x raised to 5 plus x raised to 5 plus x raised to 5 all over 2x cubed times x squared. Simplifying this for the numerator, we will be obtaining 3x raised to 5, and then the denominator, we will be obtaining 2x raised to 5. But again, we can cancel this one, and we'll be left with 3 over 2, or if you want in decimals, this is 1.5. This is the answer for our problem. Let's leave with that. So just to recap, our first step is to simplify the given equation into this, and then once we have this expression, or this equation rather, it is now more evident that we can apply the AM-GM inequality, and upon applying that one, we obtain this equation, x equal to y equal to z, which eventually in turn easily solved what we want. Yeah, so I hope you enjoyed that one, and I hope you learned a lot from this video. So make sure to check out my playlist on my YouTube channel on more challenging problems like this. And yeah, so if you have any problem in mind, you can comment it down below, and I'll try to check if I could solve that one, and maybe that would be my next video. So yeah, but that's about it. Have a nice day.